Hey there guys, in this session we are going to bust a myth. Before telling what's the myth, if you have not watched my last video, go and watch it first. Let's begin our video with a short intro guys. Before telling the myth, check out my prototype. I have connected two objects of same masses as M1 as mass 1 and M2 as mass 2, connected by a rubber band. Let's not try to go on its physical structure guys, but let's see how do it react to gravity. So now for the purpose of height, I have made markings on the left. You can check out on the left, and on the count of 3, 2 and 1 I am going to lay it down. So it's 3, 2, 1. What did you see guys? Of course, as everyone you must have seen just a normal throw. This was by your naked eyes. But what under a slow motion camera? This is at 960 fps. Wow, just amazing guys. So let's take a detailed look of it. So I am going to stop the video and let's understand the forces acting on it. G stands for acceleration due to gravity, here taken as 9.8 meter per second square. PE, the potential difference, which is acting opposite to gravitational force. And M1 and M2 are the masses which I have considered in this, which are equal to each other. I have resumed the video and you can check out. The second object stays in the sky defying gravity. Let's understand theoretically. For the purpose of solving this myth or the sum, what I'm going to do is I'm going to draw the structure, or I'm going to say as I'm going to draw the objects which are connected by a rubber band and try to understand the prototype of it. So there goes the object, that's mass 1 and mass 2 I have connected by a rubber band. So the rubber band is storing the potential energy between the two objects, and you can see mass 1 is equal to mass 1 and mass 2 is equal to mass 2. So here we know that rubber band is making a link between M1 and M2 and it is storing a potential energy while we are holding against the gravity. So potential energy, so the formula to calculate the potential energy is mass into gravity into height. As again told you before, mass 1 is equal to mass 2. So guys, as we know that acceleration due to gravity is considered always as 9.8 meter per second square. That is acceleration, so we considered as meter per second square. The forces are acting opposite, the gravitational force and the potential energy, so the object stays still in the sky for some time. So I have measured the masses of both the objects and the mass is equal to 250 grams. So here 250 grams we are not going to consider in grams, as we know that SI unit of mass is kg. So I'm going to convert in kg. So it will be equal to 0.25 kg. I'm going to consider as 0.25 kg. Later I'm going to consider the acceleration due to gravity as 9.8 meter per second square. And for instance, I have taken height as 1 meters. As I have shown you in the video, I have taken height as 1 meters. Now it's time to simplify all the values. So now it's clear that both the values are similar. So what does this indicates? So we are going to divide them up to understand the forces are equal to 1. So what I'm going to do here is I'm going to divide 2.45, that's gravitational G1, as P1. So it's 2.45 by 2.45. So 1 denotes the forces acting are equals. You can see that it's 1. Therefore the object remains in air for a fraction of a second. That's what I wanted to show you guys. So you can see here, we can say that myth is busted.
Hush.